Welcome to the Chapter 5, Lesson 5 video on SSS and SAS. By the end of the lesson, we should be able to answer the question, how do we use SSS and SAS to test for triangle congruence? Let's hop right in with the SSS postulate. This postulate states that if three sides of one triangle are congruent to three corresponding sides of another triangle, then those triangles are congruent. So the SSS stands for side, side, side. That is required to use this postulate to say that the triangles are congruent. So this example gives us two triangles, but it doesn't actually tell us how the triangles are set up. It just says the relationship between some of the sides. So side PQ is congruent to side ML, PR is congruent to MN, and RQ is congruent to NL. And the goal is to write a congruence statement for the two triangles. So triangle, ABC is congruent to triangle DEF, obviously using the letters that are given instead. So there are two ways to do this one, and I'm going to start with the drawings. So the first way is to say, okay, well, PQ, and I don't have any idea what this triangle looks like, but there's PQ, and it's congruent to some other triangle side ML, okay? And then the next set of information says that PR, well, the only way for me to draw PR is to come off of P in another direction and create R, and then it says it's congruent to MN. So I'm just going to try to draw it congruent. And actually, while I'm here, let me go ahead and draw my tick marks to say that they are congruent. And then it says that RQ, well, here's RQ. It's already, the points are already there. We just have to connect the sides. RQ is congruent to NL. Same thing over here. So this allows us to visually see the relationship between the two triangles, to write the congruent statement, and remember that order matters. So if I say triangle PQR is congruent to triangle, then we have to follow it. So P to Q is the first congruence with the one tick mark. So that means we have to go ML. So PQR, MLN. That's the only way, the only thing that you have to be extra careful of is to make sure that your order matters. The other way to do this exact same problem is to just match the letters up. So if it says PQ is congruent to ML, then I can say that triangle P is congruent to triangle M, and I can just start with those letters. Then Q is in the same spot as the L. So instead of drawing the triangles out, we're just matching the letters. And so we already have, I'm just going to take the red and double check here. We already have the P and the M matching up. And then this one says R and N, so we don't have that. So R and N, but we do have R and N over here, and we already have Q and L over there also. So that was just me making sure that they all did match up in this set of given information, and we have the same statement here. Triangle PQR is congruent to triangle MLN. As we make our way to the next postulate, it's important to get just one more little bit of information about triangles. It says, in a triangle, the angle formed by two given sides is called the included angle of the sides. The deal with this particular look is I want you to think like it's the nose between the whiskers. So that angle there kind of looks like a nose of a mouse maybe. So here's the nose, and then here are the whiskers. Those tick marks creating whiskers are showing congruency. So the nose between the whiskers. So in this example, angle A is the included angle of AB and AC. And notice that they do match letters there in that statement. Which leads us to our side angle side postulate. That's what SAS stands for. That if two sides and the included angle, so that nose between the whiskers, so if the two sides and the included angle of one triangle are congruent to two corresponding sides and the included angle of another triangle, then those triangles are congruent. So you are looking for that nose between the whiskers in order to get the side angle side relationship. Angle is in the middle of those two sides. So if we look down here at this example, I have XY is congruent to PD over here, because these are kind of flipped around, but we have PD and XY. Then I have an angle that's congruent, and then on just the other side of that other piece is also congruent over here. So this is the nose between the whiskers, and this is the nose between the same whiskers. So these are congruent triangles, and I can write them in order, and we just have to make sure we're following it. So if I'm gonna start with X and then go to my included angle, X, Y, Z, then because this is the single tick mark side, I will have to start at P, follow that single tick mark down to the included angle, so P, D, Q. And again, these markings down here are just helping us to pay attention to the order in which we are writing our congruence statement. So what we're going to be asked to do now is determine whether triangles are congruent. And we're going to be having these tests that we're going to be completing. And so right now this lesson just focuses on two tests, the side, 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 and the side, angle, side. Now I know right now that I can't use side, side, side because I don't have enough information about this third side here. But I do have an angle that is in between two congruent sides. So because it is the included angle, it is that nose between the whiskers, I can say that the two triangles are congruent by side, angle, side. And so that's what we're going to write. We're going to write the congruent statement, making sure that we're paying attention to the order. So I'm just going to start at D and go to B, R. So triangle DBR is congruent to triangle HKA. And it has to be HKA because I decided to do DBR. Again, if you started at BRD, then your answer on the other side would be KAH. It's not that this is the only answer, but the correct answer just has to be in the right order. I'm missing my triangle symbol there. The other piece of this is to make sure to say why or how you know that. So these two triangles are congruent by side, angle, side. So in this example, it looks like I have an angle that is congruent and two sides that are congruent. In this triangle, RMA, it does look like it is the included angle. However, over here, this is not the nose between the whiskers. If the nose is up here, the whiskers are over here and things have gone wrong. So these triangles are not congruent. But we could go as far as maybe thinking about what would be needed in order to make them congruent. So because we do have these sides that pretty much match up even in location, like this is on the top, top, and then bottom, bottom, is that we would need angle T to be congruent to angle M. So I'm just thinking about things that we would need to have happen. Okay, we would need that to happen, or we would need side RA to be congruent to side UV. And so those would be our two options that would give us a side, angle, side relationship, either side, angle, side, or this side, angle, side, depending on which extra set of information you might be needing. But based on what's given, please understand that the answer to this question is that they are not congruent, but just some forethought into thinking of what would actually be necessary to make them congruent. Another example here, but if we look, the angle that is in here is the nose between the whiskers, nose between the whiskers. The trickiest part about this is going to be your congruent statement. So if I say that triangle KSR is congruent to triangle, well, now we have to think about what's going on here. K to S is the two tick marks to the included angle. So I'm going to have to start at N, follow the two tick marks to the included angle. So this is NSO. So again, because of the way this is kind of flipped around here, notice that there's two tick marks here and then here, instead of it just being like top and bottom or whatever, you have to just be extra careful about your congruent statement. And then we are going to say that it's congruent by side, angle, side. So in this example, it says to write the congruent statement for each pair of triangles, and the hint is to draw them. I know that at the beginning of the lesson, I talked about how you can just match up the letters, but we want to also be able to say how we know that these triangles are congruent. So I'm just going to go ahead and draw them. So MA, and I'm consistent with how I'm drawing it. MA, every single one is going to end up pretty much the same in my orders here. So MA is congruent to TH. Going to label that with a tick mark. Then, so we're done with this one. Actually, let me do that in red just so it matches. All right, now we're going to grab a blue here. We're going to go MX. So this has to be the X coming off here. It's congruent to TG. So this has to be the G here. And we have drawn that one. So I'm only crossing them out as I go just to show that I have completed that part of the drawing. And then it says AX is congruent to HG. So I'm going to give those three tick marks, color green, and that's good to go. So using this information, I can write my congruent statement that triangle MAX is congruent to triangle THG, again, using the following in order, consistency following their congruent statements, and this one is by side, side, side. I don't have any angle information. I have all their side information that's congruent. Okay, I'm gonna do the same thing. GF is congruent to BV, done with that one. Then I have GH is congruent to BN. And then the other piece I have is actually angle information. Angle G is congruent to angle B. Well, that's perfect, but I am gonna go ahead and finish out my triangle here, so they do actually look like triangles. And this one is giving me the nose between the whiskers, nose between the whiskers. So I'm gonna go ahead and say that they are congruent by side, angle, side. So I'm gonna go triangle FHG is congruent to triangle VNB by side, angle, side. So what's just a little bit different about this problem is that it starts by giving me an angle relationship, and I don't want to start with the angle relationship when I'm drawing. I'm going to go ahead and start with my side relationships that they're giving me here. So ZC is congruent to YN, and then it says CX is congruent to NH. All right, so I'm going to go ahead and finish off my triangles, but I can't label them as congruent right now. And then the other piece of information that's given to me is that angle C is congruent to angle H. Okay, well, we were good with angle C because that's the nose between the whiskers, but H over here is not the nose between the whiskers when drawn using the other information. So this example shows me that these triangles are not, so the triangles are not congruent. Okay, they do not match. They don't pass the side, side, side or the side, angle, side test. So this concludes the lesson 5 video on SSS and SAS and the essential question, how do we use side, side, side and side, angle, side to test for triangle congruence? Is that if 3 sides or 2 sides in the included angle are congruent between the triangles, then the triangles are congruent.